All right, now let's talk about related conditional statements. So we have three related conditional statements. So if we start with an initial conditional statement, the original conditional statement, now an if-then statement, and in this case, let's use this if P then Q, right? So P is some hypothesis, Q is some conclusion. So then we have three basically spin-offs or alterations of our conditional statement. So we have a converse. All right, so a converse basically swaps the hypothesis and conclusion, right? Instead of, let me do it this way. Instead of if P then Q, a converse, says if Q then P, right? So if it's cloudy, then it will rain. The converse of that is if it's raining, then it's cloudy, or if it's cloudy, then it rains. If it rains, then it's cloudy. All right. So then next we have inverse. All right. So an inverse actually negates the hypothesis and conclusion. So notice that we have the same order, if P then Q, except we say if not P, and this symbol means not. Okay. So if not P, then not Q. All right. So that's what an inverse does. So if my original statement is if it's cloudy, then it will rain, the inverse of that would be if it's not cloudy, then it will not rain. All right. And then finally, we have the contrapositive. So the contrapositive basically it's the converse and the inverse combined, right? It actually flips and negates the original. So if the original is if P then Q, then the contrapositive would say if not Q, then not P. Okay, if not Q, then not P. And so that's the contrapositive. So if we go back to the original, if it's cloudy, then it will rain, the contrapositive would say if it doesn't rain, then it is not cloudy. Or if it's not raining, then it's not cloudy. Okay. All right. So here's some examples based on some geometry. So we have the initial, if the measure of angle A is 15, then angle A is acute. So the converse would be, well, if angle A is acute, then the measure of angle A is 15. The inverse of that would be if the measure of angle A is not 15, then angle A is not acute. And the contrapositive would say if angle A is not acute, then the measure of angle A is not 15, right? Okay. All right, so that's how you find the converse, inverse, and contrapositive given an initial conditional statement. Okay, so converse, you flip the hypothesis and conclusion. Inverse, you keep the same order, but you negate. So you say if not P, then not Q. And the contrapositive, you both flip and negate. So you say if not Q, then not P. So let's take these statements again and see, just evaluate the truth value. So, so the original conditional, if the measure of angle A is 15, then angle A is acute. That's true, right? If I have an angle that's 15 degrees, then that's obviously between 0 and 90, less than 90. So therefore, that's true, right? If an angle is 15 degrees, it must be acute. All right. The converse, if angle A is acute, then the measure of angle A is 15 degrees. Well, for every acute angle, does every acute angle measure 15 degrees? No, right? And we can easily find a counterexample. What about 16? What about 80? There's a lot of them, right? So let me say 60. So 60 degrees would be a counterexample, right? To prove this false. Now for the inverse, if the measure of angle A is not 15, then the angle is not acute. Well, our counterexample that we just used, 60 degrees, works for this one as well, right? So I found an angle that is that is not 15, but it is acute. Okay, so the hypothesis is true, but the conclusion is false. That's how you find a counterexample, right? All right, and then for the contrapositive, if an angle is not acute, then the measure, or excuse me, if angle A is not acute, then the measure of angle A is not 15. And that's true, right? That one's a little tricky to think about. But if an angle is not acute, like think of any not acute angle. That would be anything more than 90, right? 90 or greater. So if I have an angle like 95, then that's not equal to 15, right? So that's not a valid counterexample. So there is no angle that's not acute that can also be equal to 15, right? So therefore, that has to be true. All right, so for all the angles that are not acute, they're not equal to 15. So what you might have noticed here is a pattern that the original conditional has the same truth value as the contrapositive. Okay, so if the original is true, the contrapositive is true, and the other way around is true as well. If the contrapositive is true, then the conditional must be true. So that sometimes you can have a proof by contradiction, and that's kind of uses that idea where if you can prove the contrapositive, then you can prove the original conditional. Sometimes it's easier to prove one or the other, and so that's handy to know. And then the other ones that have the same truth value are the converse and the inverse. So they always have the same truth value. So if one is false, the other is false. If one is true, the other is true. Okay. Now it can happen where they all have the same truth value. So sometimes the converse and the inverse have the same truth value as the conditional and the contrapositive. But that's not always the case. All right. That's actually when you have a biconditional or if and only if statement is where they all have the same truth value. All right, and down here, so statements that have the same truth value are called equivalent statements. Okay, and just like we mentioned, a conditional and its contrapositive are equivalent, and so are the converse and the inverse. Okay.